So we have to see that in this part that we have to bring down the diesel petrol consumption, and also we have to see that we have to lower down the cars which we are using on diesel and petrol because of two causes. The main sustainability point of view is that diesel and petrol is having very limited of time left, right? Do you know that? How much amount of resources we have? Dia, can you tell me how
Um,
much amount of resources we have diesel and petrol? We have got a resource of what? Around 30 years left, isn't it? That's it, right? Do you know this? That
no.
we have got a resource of 30 years left, right? Because because this is a non-renewable source of energy, right? Isn't it? Right? We are using at a very faster pace than the nature can manufacture it, right? Or refurbish it. So this is very important that whenever we are thinking about the sustainability part, diesel and petrol has to be less used so that the future generation can use it. Second is that whenever we are using diesel and petrol, the biggest sustainability threat is that you have to understand that it emits oxides of nitrogen, as you brilliantly said. What's the biggest issue of this? This oxides of this nitrogen, right? When it goes to the good atmosphere, right? It mixes up with the rainwater. So NOx I'm writing plus H2O, right? Gives you what? HNO3. And this falls, right? This falls as acid rain, right? What does it destroy? It destroys the calcium carbonate statues, right? The calcium carbonate statues, right? Or the buildings or the floorings of the calcium carbonate, right? Isn't it? Do you
Yeah.
know what is calcium carbonate? Marble stone. Have you heard? Have you seen
Yes.
marble stone flooring site? There are many museums or old architecture buildings, right, which have got marble calcium carbonate walls, right? Right, the palaces, right? 100% calcium carbonate which are there, right? Isn't it? So these will be degraded by what? Acid plus carbonate gives you what? Can you just guide me? What does acid plus carbonate gives you? Tell me.
Salt plus
Salt, water plus
and
carbon dioxide, right? Isn't it?
yeah.
Mixing. So this is very important that whenever we are taking acid plus carbonate, right, it gives you salt, water, and carbon dioxide. So this itself is a very important and interesting part we have to follow, right? Now going to this next part. Now, if you see, whenever we are seeing this, the structures will be destroyed, and it also reacts with iron, right? This HNO3, right? It reacts with iron to give you FeNO3, right? Fine, fine.
Yeah.
Is it clear? Plus, this will be soluble in water. Iron is not soluble in water, right? So FeNO3 is soluble, thus it comes off as flakes. So this is as per the sustainability part, we are damaging the buildings and the iron structures which cannot be used by the future generation. Is it clear? So
Yes.
there's a need, right? Both are need a push of coming, right? What's the push? Push is we to see that how to make the diesel and petrol to be used for a longer time, means not dependent on it, cutting down its use. Second, what the gases is coming out? Nitrogen dioxide, sulfur dioxide, right? These gases which is emitted out of our cars, right? Even sulfur dioxide, right? Mixes with rainwater. See, to give you what? H2SO4, right? See, it falls as aqueous acid. Is it clear to you? Is
Yes.
it clear to you? So this sustainability portion, we have to be very sure of the in this context that we have to eliminate these gases which is coming out. So what's the other alternative? The other two alternatives is that if can we go for an electric vehicle? Yes, we can, right? So are you understanding this? In the UK, the UK government has giving enormous tax benefits if one uses this electric vehicle, isn't
Yeah.
it? The road tax is zero, right? There's no road tax. The insurance cost is also low. So they are trying to lure people, right? They to attract people that, hey, shift to electric vehicles because no sulfur dioxide will be emitted, isn't it?
Yeah.
No nitrogen dioxide will be emitted, right? Now you might be thinking that why can't we use the other reaction like this, right? Right? This is used in what? Can you tell me where this reaction is used? We can also use a hydrogen fuel cell, right? But there's a but. Hydrogen fuel cells cannot be used to help in the sustainability feature, right? Why? Because hydrogen fuel cell has got some limitations of handling, right? Isn't it? The gas of hydrogen, right? This is very important, right? Now, how does this threat? Hydrogen is very risky gas, right? Very risky. It will be reacting with oxygen, right? And it will be really but has to be kept under very tight situation and very organized and very what a very robust system, right? Is it clear?
Yeah.
Hydrogen gas storage is the main problem, right? Storage and transportation. Even a small spark can create a huge blast. Is it clear? The
Yeah.
only thing which is holding us back is this. The hydrogen gas storage and transportation is really very difficult, right? Isn't it? And if you can see this reaction is wow, right? Isn't it? See, hydrogen, you are combusting with oxygen to give you water, right? This gives you enormous amount of energy. If you burn petrol, right? If you burn petrol plus oxygen to give you carbon dioxide, water plus energy, right? This reaction gives almost 5 to 6 times the energy which is given by petrol. Is it clear? Per mole of petrol. Did you get this thing? What I'm saying? Right.
Yeah.
So why is holding us? What is holding us back? Right. This reaction is enormous. Great, right? Why? Because we don't also release gases, right? Such as sulfur dioxide or nitrogen dioxide or carbon dioxide is released. Is it clear? Carbon dioxide is a safe gas, but more important is this, right? These gases are released by the petrol and diesel vehicles. Did you get this point? Yeah.
Correct.
Now till now, so we have got the alternative to use hydrogen. See, hydrogen can be easily got from electrolysis of water, right? Water is abundant around us, right? Lakes, rivers, right? Seas. If we electrolyze water, we'll get hydrogen, right? The cheapest source. It will be priceless, right? It will be almost 100 the price of petrol, right? Probably, right? But what is holding us back? Holding us back is this, that safety and storage, right? That to be solved, right? It's very risky gas, very risky gas. Can you tell me where is hydrogen gas used? This powerful energy which is given out. Have you seen? Do you know where this gas is used?
Um.
Have you seen rockets by any chance? That the rockets, the base contains some tanks which is actually there. Have you seen
Oh.
that? Rockets which is going to the moon, to the outside Mars. Have you seen some cylinders at the base? Have you seen
Yeah.
rockets which stays up? What is there in these cylinders? There
How is it
we are
hydrogen?
having what? We are having oxygen. This reaction takes place in the rockets, right? Is it clear? Right?
Yeah.
Because we need high amount of energy, right, to drive. We cannot use petrol over here because this won't give you the drive, right? The drive to go against the gravitational pull and force this rocket out of the orbit. Sorry, outside the Earth attraction of the gravity. Did you get this thing? This
Yeah.
reaction happens. So this is very important that if yes, there are cars which are there which will be starting even most probably BMW is saying that they will be offering hydrogen fuel cell cars by 2026, right? So this is the problem, right? This hydrogen is a very unsafe gas. It's very risky, right? The entire building will be burst off, right? If anything, any small, because it gives huge lot of energy. Is it clear? Second is that you are this is a renewable source of energy, isn't it? You get it from the H2O, right? H2O electrolysis. So this is very important that whenever we are seeing this reaction, right, we have to understand that this reaction can be used. And yes, there are cells which are there which are operating, right? So this is very important that the cell which are actually operating is called as fuel cell, right? There's a picture over here. There are buses, I'm telling you, there are buses, but very few, which are there in Germany also they have started. But yes, so this will be replacing all the solutions of the power which is needed by our transportation, right? Now, now in this thing, do you know what's another feature? The product. Can you see the product? The waste product, isn't it?
It's
The
water.
waste product is what?
Water.
H2O, right there, water. So this is also important that waste product will be water. So that also will be helping us, right? Now, how does the fuel cell look like there? You have to draw the diagram. Can you open the book, please? Page 123.
Yeah. I've opened
Send me
it.
a message in Skype. Page 123. Diagram. Open it and write e to the power infinity over here. Right? I really hope that you'll be drawing the diagram, right? D to the power infinity, right? Fine.
Yeah.
Is it clear? Master these two chapters. Yeah, masters these two chapters. I'm telling you, this is the critical chapters which maximum 99% of the student they lose marks, right? So in the sustainability field, this fuel cell will be a turnaround thing. What do you do exactly? You're taking what you're taking the electrodes over here. These electrodes are what perforated electrodes, right? Isn't it? Right, sponge, right? Like a sponge has got, right, fine pores. We are taking 2 electrodes over here. Now coming to this thing. Now over here, we have to see that that this. Now can you just mark it in the book quickly? There's a write down over here. This is missing in the book. Positive, negative, right? Please write down.
Okay.
Right. Same thing you have to write, right? Positive terminal, right? And negative terminal, right? Isn't it? Or right? Or positive electrode or negative electrode. Have you wrote?
Yeah.
Thank you
Let me
so
do.
much. Thank you so much. And we know what negative terminal will be there where electrons will be released, right? Isn't it? Electrons released. Is it clear to you? Fine.
Yeah.
This is very important that whenever we are seeing the negative terminal, negative terminal, the electrons will be released, right? Over here. That's the reason you have to show this reaction. What happens? Now you have to practice this reaction, right? Hydrogen is pumped from the hydrogen cylinder into the negative terminal. Is it clear?
Yeah. It's clear.
So hydrogen plus 4OH minus gives you a 4H2O plus 4E. Clear?
Okay. Yeah.
You have to practice this.
Okay. I will.
Means there are many times you can forget, but you practice this. So hydrogen plus 4OH minus gives you H2O plus 4E. Can you see the number of electrons which is given out, right? A whooping 4 electrons, right? Whooping, right? This electrode, please note this down. This is not in the book. This electrode does not allow electrons to pass to the next. Is it clear? To the next chamber, isn't it? Fine.
Okay.
Is it clear? This is also called as hydrogen fuel cell with alkaline electrolyte, right? There are 2 hydrogen fuel cells. We'll be studying the AS level, A level. Hydrogen fuel cell with an acidic electrolyte and alkaline electrolyte. They have underline this, right?
Underlined.
Underline the alkaline electrode, mark a star, right? Alkaline electrolyte, right? Isn't it? Fine. And they are going to take a note quickly and write the notes over here afterwards, right? Here there's a huge gap, right? In the bottom over here. Take a very clean handwriting right over here. That this electrode has got a special feature that it does not allow electrons to pass through it, right? Isn't it?
Okay.
Is it clear?
Yeah.
Have you wrote?
Yeah.
See, this is in the A levels and the IBDB book, right? So electrodes will be not allowing electrons to pass, right?
Yeah. Got
Isn't it? Now write that the electrodes will be allowing the OH minus to pass, right? Isn't it? Got it?
Yeah.
You make the pore size, right? You might be thinking how, right? Is it something they're punching some card to entry, some iCard? No, the pore size, right? Right. The pore, you have to make sure that have you wrote this? Yeah.
Yeah, I wrote it down.
Now tell me one thing, that the electrons cannot pass through it, right?
No.
So the electrons will be forced what to follow the wire, isn't it? Forced. Make sense?
Yeah. Got it.
Isn't it? Got it? What's the trick? The electrons will be forced to pass through this wire. And passage of electrons in a wire is called as electricity. We learned it physics also. You learned it physics. The passage of electron through a wire is called as electricity, right?
Yeah.
Clear? Okay, thank you so much. So this is very important, that whenever we are pushing this electrons, right? This will be flowing through this electric wire. That's all. Now we need OH minus, right? Over here, can you see this? We need OH minus. Where the OH minus is coming from? Tell me. From the positive electrode reaction. See, isn't it? It is getting generated over here, right? Fine. Can you understand this reaction happening over here, Diya? Have you wrote positive and negative? This is missing in the book, Diya.
I wrote it.
Lovely. Positive and negative, have you wrote? Isn't it?
Yeah, I wrote it.
Perfect. Perfect. This is perfect. Now after this, what we are doing? We are getting what? We are getting the 4OH minus over here, right? This is generated and this will passing through the electrode. See, electrode allows to pass, right? OH minus, right?
Okay. Yeah.
And it passes through this also, right? This electrode, negative electrode. And it reacts with hydrogen, right? OH hydrogen to give you what? H2O plus 4E. Is it clear?
Yeah.
Do you understand this thing? So just make a arrow like this.
Made arrows.
Perfect. So this is the two reactions you're having. You have to memorize this reaction also, isn't it?
Okay.
That's very important. So if you add these two reactions, what happens? This gets cancelled. Cancelled. 2H2 we cancel with 2H2. Fine. So ultimately we are getting what? 2H2 plus O2 gives you 2H2. Fine.
Yeah.
Clear?
Yeah.
So what is the product you're getting? Water.
Okay.
See, water is a waste product. We cannot think of a better waste product than this, right? We can use it in drinking also, right? Isn't it?
Yeah.
This is done in the spacecraft, right? That the drinking water, what they get. No? This is, see, all benefits. Pure water, right? Pure water is a very difficult thing to get, right? In many countries, right? So this also can be used to what? This can be used to generate a huge amount of energy, and yes, waste product with water. Now you have to understand that we will be getting questions like this. Can you open your book quickly?
Yeah, I've opened it.
Mark this important. Yeah.
Where? Okay, there.
Mark this important. This is page number 123, I guess, right? 123. And this is very important for sustainability part, right? Very important this, right?
Okay.
Non-renewable source of energy we are taking, right? Isn't it? Fine. Isn't it? No pollutants are produced. This is not sustainability, right? We are doing something which does not hamper the future generation, right? Is it clear? You guys think? So this is very important, that what the advantage we are getting? The advantage we are getting is that they do not need to be electrically recharged, right? Isn't it?
Yeah.
No pollutants are produced. What are the disadvantages which are having? Main disadvantage is hydrogen is highly. This is the part where it's holding us back, right? This is the part. Hydrogen cannot be stored and transported easily. Write down over here, right? Thus, hydrogen cannot be easily stored, isn't it? And transported, right? Isn't it? It cannot be easily and safely, huh? And safely. Is it clear?
Yes.
So highly inflammable, so it cannot be stored and transported easily. Did you get this thing?
Yeah.
So this is very important, right? When you're doing it, right? Fine, there. Just send me a message, please.
Okay.
See 7.6, new chapter. And I think that you have to complete all these things to go for a revision, quick revision, right? There, go for a quick revision, and try to do one thing, there. Can you do one thing? That will be great.
Okay, what should I do?
I'm telling you. I'm thinking that how much to pump you, means how much to put load on you, means pumping load on you. Yeah, do one thing. It's a combination of three metals. Send me a message. 124, question number 5.
Okay, 1 minute.
Question number 5. No,
Yeah.
7.6, not a quick one. 7.6 detailed one, right? Sorry. Other chapters quick one, right? I hope that you know, right? Yeah. I meant that, right? I'm sorry for that. Fine. Just wait, I'm just switching. So that was all about what? This chapter was all about the sustainability approaches we are taking, right? That will be also in your paper number 2. See, these are all sustainability measures, right? So UK is a country which really, we are God blessed to be in this country, that they are taking all the sustainability measures, right? That whatever you are doing, see, all these are sustainability, right? Greenhouse impact, right? We have to get literate, right? Global climate change. See, can you understand this thing? That there so there's some storm which is happening where when rain does not happen, as per the pollutants, right? There's these life cycle assessment, recycle, use, right? Fine. Okay. So thank you so much. So